This is Mrs. Downey, and we're going to do a quick review of 5-1 and 5-2. This is all a new chapter on zeros, sublinear factors, and polynomial functions. Our bell activity today is to review, watch this review video. The first problem says, write each polynomial in standard form. What is the classification of each polynomial by degree and by the number of terms? Well, the first thing you want to do when you put these in order, you put them in order by the powers. So you look at x, and here we've got a 3x, a 9x squared, and a 5. So you want to put these in the highest power first. So 9x squared plus 3x plus 5. Okay, the highest power is a 2. So it's a quadratic, and it's 3 terms, so it's a trinomial. So it's a quadratic trinomial. On the next one, we've got several terms. Notice that we have like terms as well. So these combine to make a 4x squared. And then we've got x to the 4th power. I'm going to put it up front. 4x would be behind here. And a minus 12. So we have 1, 2, 3, 4 terms. And the 4th power, or the highest power is 4. So it's a quartic polynomial of 4 terms. Q-U-A-R-T-I-C, quartic polynomial of 4 terms. The next thing we talked about were turning points and end behavior. Turning point is just a place where the graph changes direction. So if it's coming down this way and it goes back up, that's a turning point right there where it switched directions, and it can turn again. It can turn several times. Okay, so that's what a turning point is. The end behavior is how the graph begins and ends. So it says the directions of the graph to the far left and the far right. So far left, far right. So this starts going up and it ends going up. So we call that an up and up end behavior. This one begins down and ends down, so it's a down and down. This one is a down and up an up and down. Okay? It says you can determine the end behavior of a polynomial function by degree n from the leading term. So if you put it in standard form, you look at the power and you can decide what this is going to do. You can also look at your a term, the a and the n. So if a is positive, you know, and your power is positive, think of 2x squared. Right? That's a parabola that's facing upwards. And when our a term was negative, we had a parabola going downwards. Remember that? So that will help you learn your a term. Now, on the powers, if it's just the power of 1, it's a straight line. That's a linear function. If it's a power of 2, it's a quadratic. It's a polynomial. If it's 3, it's either going to look like this or like this one. It's either going to have a down and up or an up and down for a cube. So they made a chart for us, and it is, if a is positive and you've got an n is even, it's up and up. Think of 1x squared. It's up and up. Now remember, if a, like negative 1x squared, if my a is, excuse me, I'm going the wrong direction. If you have 1x squared, so my a is positive, my power is even, it's upwards facing. If my a is negative, this is my negative row here, then we know that negative 1x squared was the downwards facing parabola. Now what happens when our power becomes odd? Okay, When it's odd, it's going to flip that first, the left end behavior. So it's going to flip this down. Okay? And for this one, if n is odd, it's going to flip this first term the other way, up. So it becomes an up, down. And for a positive a, it's down, up. So just remember to flip. Remember your 1x squared and negative 1x squared. Okay, up, up, down, down. And if you've got an even power up here, they're going to continue to do that. If you've got an odd power, it's going to flip this first, the leftmost side, the other direction. Okay? That's the best that I can do to help you remember. I always have to refer back to a chart or sit there and think through that. Okay, on the next problems, it says consider the leading term of each polynomial function. What is the end behavior of the graph? And check your answer with the graphing calculator. So they give us y equals 4x cubed minus 3x. Well, the leading term is 4x cubed. It's in standard form already, so we're just going to look at this, 4x cubed. So my a is positive and my n is odd. So that means I've got this, and it's flipping because it's odd. It's going to flip the leftmost side, so it's going to go down and up. Okay. On this one, it's in standard form. My leading term is negative 2x to the 4th power. This is even, and this is a negative, so it's going to be down and down. If you were to plug these into a graphing calculator, these are what they look like. The down and up, and the down and down. So I have a take note here, and it says, like I said, if you've got x to the 1st degree, 1st power, you've got just a straight line. If you've got x squared, you've got a parabola. If you have x cubed, you can have one of two things. You can have 0 turning points or 2 turning points. Okay? As a 1st degree has no turning point, and x squared, the degree of 2, has 1 turning point. So 0, 1, here, let me do it this way. 0, 1, none, and 2. Problem 1 said, what's the factored form of x cubed minus 2x squared minus 15x? The first thing we have to do is factor this, factor x. They all share an x, so take out the x. And what's left over is x squared minus 2x minus 15. Now we can do our magic x to say what 2 factors of 15 add up to be negative 2. Oop, that's a negative 15, excuse me. And so it's going to be a negative 5 and a 3. So we're going to have this x, don't forget to leave that here, and then x minus 5 times x plus 3. And there it is factored. Okay, that is the factored form of this equation. The next problem, problem 2, says what are the zeros of y equals x plus 2 times x minus 1 times x minus 3, and graph the function. So we know that the zeros, we're going to just turn this to 0 and solve. So 0 equal x minus x plus 2, excuse me, times x minus 1 times x minus 3. What makes this true? When x is negative 2, a positive 1, or a positive 3. So these become our x-intercepts, negative 2, 1, and 3. And you would plot those on your x-axis. There's your negative 2, 1, and 3. Now you would pick x points between these dots. So somewhere in between here, you're going to pick a point. Let's look at what negative 1 does and see if it's positive or if it's negative. If it's positive, we know this is going to be going upwards. If it's negative, it would be going the other way. So when you plug in a negative 1, you find it is positive. It comes out to 8. So when you plug in a negative 1, you get a positive 8. So we know this is going to go up, down, and now you have to pick a point between these two. So pick 2, and you find if you plug 2 into this equation, you're going to get a -4, which would put you here, which means, okay, and now we're going to go back up through our intercepts. So remember, these three things, -2, 1, and 3, those are your x-intercepts. Okay, then you pick a point in between and see if it's positive or negative, and then graph. So the end behavior of this would have been a down-up. The next problem says, what's a cubic polynomial function in standard form with zeros, -2, 2, and 3? So it meant that, whoops, let me get my pen back. So it meant when you have a 0, -2, that had to come from an x plus 2, right? So that would have to be a -2 plus 2 is equal to 0. And then you take the opposite of this, x minus 2, and the opposite of that is going to be x minus 3. So there's the equation, and change your 0 to a y. Now we've got the equation that created these zeros. Now we have to put it together. So let's just, we know this, right? That's going to be the difference of 2 squares. That's the factored form of a difference of 2 squares. So it's going to be x squared minus 4. And if you don't remember that, then you just FOIL everything out first, outside, inside, and last. And you'll come up with this. And then times x minus 3. So we're just multiplying all three of these binomials back together. So I'm going to multiply x squared times x, that's x cubed. Outside is -3x squared. Inside is -4x. And last is a positive 12. So there's y equals, excuse me. And that's not going to work. So this is our answer. Okay, this one you'd work very much in the same way. So notice that you've got two -2's, so that's going to come from y equals x plus 2 times x plus 2, and then our 2 and our 3 would be x minus 2 times x minus 3. Okay, and now we know those squares are going to be x squared plus 4x plus 4, and this is going to be x squared minus 5x plus 6. Now combine your like terms, and you've got 2x squared, 4x minus 5x is -x, and 4 plus 6 is 10. And that's your answer. Our last problem for review is problem 4 of 5.2. What are the zeros of f of x equals x4 minus 2x cubed minus 8x squared? What are their multiplicities, and how does the graph behave at these zeros? So we have to factor this out. So we've got f of x equal, and all of these share an x squared. So I'm going to take out an x squared. So that's going to be x squared minus 2x minus 8. And we can factor this, and we know from the book said that this is going to be x minus 0 times x minus 0, which is just x times x, right? And now let's factor this part out. So what, 2 factors of -8 add up to be -2? Well, x minus 4 times x plus 2. All right, and the magic x would have gone like that. What 2 factors of 8 add up to be -2, -4, and positive 2. All right, now we've got these. Now what are our multiplicities? Well, we have at x minus 0, we've got a multiplicity of 2. So at the origin, we're going to have some type of parabola, right? Because it is a square. And here our 0 is going to be a 4 and a -2. So we've got a multiplicity of 2 at x minus 0. Now when you graph this, did I put this here? No, we did not. So when you graph this, it means we're going to have some type of parabola here or here. And at 4, we've got some kind of straight line coming in. And at -2, we've got some other kind of straight line because it's just a multiplicity of 1. So we don't know if it's going to do this, or you have to pick the points in between and look at those. Okay, so when you finally graph it, it looks like this. Okay, and there it is. Okay, so like I said, at -2, it was some kind of straight line. There it is. At 4, it was some kind of straight line. There it is. And at 0, there was some kind of parabola, and it was this. It was downwards facing. So we have this shape come out of it. Okay. There we go. Get that out there. There you go. So there's the graph of it. That concludes this lesson, and we will now grade our papers quickly and move on. Okay, so I'm not going to go through these individually. You can check them at home. So here's on 5-2, let's go back to 5.1, just a second. Okay, here's 5.1 polynomial functions. So here are the answers, and you can look at these and check yours against them. Just pause the video. And next page. You can pause the video again. Next page. And pause the video again. And I think that's, oh no, there's more. And this is the last of it. Yes. Now the answers for 5.2. Okay, the answers for 5.2 right here. I wrote this bigger so people could see at the back of the room, but I just left them. Okay, pause if you need to. Moving on. Here's 6 through 12. Let me pause the video. Moving on. And let me pause the video. And moving on. And that was it. So, thank you. That concludes our lesson, and thank you for watching this video.